Welcome. I'm presenting Automatic Intonation Assessment for Computer-Aided Language Learning. This article was written by Juan Arias, Nestor Yoma, and Hiram Vivanco from the University of Chile in Santiago. This article was published in Speech Communication in 2009. This paper discusses the relevance of intonation in second language acquisition, the design of a system to evaluate intonation in second language learning, the use of correlation to compare intonation curves as a pattern recognition problem, text-independent system to assess word stress in second language learning, and it evaluates dynamic time warping alignment robustness. Typical suprasegmental features of speech are pitch, loudness, and speed. The suprasegmental elements in this article are pitch, loudness, and length. Pitch being the perception of fundamental frequency, the acoustic manifestation of intonation. Loudness meaning the size or the amplitude of the vibration. And length is the duration of the utterance. Prosody is the rhythm, stress, and intonation of speech. It may reflect various features of the speaker or the utterance, such as the emotional state of the speaker, or the form of the utterance as a question, a statement, or a command. It may detect the presence of irony or sarcasm. Emotions and attitudes are expressed and reflected by the intonation that people use when they speak. The same sentence may show different attitudes depending on the intonation. Intonation is central in the communication process. Many times, the way you say something is as important as what you say. A single sound can be significant, such as ah. It can be said in different tones, suggesting a variety of meanings, such as agreement, doubt, pleasure, or criticism. Ah, I see you opened my report card. Ah being a medium pitch. Ah, I love presents. Ah is a higher pitch. And ah, did you forget to wipe your feet? And that's suggesting a lower pitch. Intonation is one of the first aspects of speech that children pay attention to and reproduce. Even babies mimic by producing intonation patterns on nonsense syllables in the late stages of their pre-linguistic babbling. Intonation is partly universal and partly language specific. In many languages, a rising tune suggests a question, a polite response, or an incomplete statement. A falling tune or tone suggests an order or a declarative statement. Language students may learn the written components of a language and may learn to read the language, but it's difficult to learn the pronunciation or the fluency, also known as naturalness of style, of the language. Naturalness of style, many researchers suggest, is fluency in a language. In this article, the researchers attempt to create an automatic intonation assessment system combining intonation and energy contour in a dynamic time warping alignment. Speech is a time-dependent process. The utterances of the same word will have different durations, and utterances of the same word with the same duration may differ in the middle, due to different parts of the words being spoken at different rates. To obtain a global distance between two speech patterns, represented as a sequence of vectors, a time alignment must be performed. Here's a sample of a dynamic time-warped sample word, the word being speech. Two different words or two different utterances of this word have been put together in the form of a vector up along the center of the graph. Here's the sample of a template of the word of our word. So you have the stored word and then the input word and then the vectors in blue creating the pattern in the center of the graph. So basically, test data is converted to templates. The recognition process then consists of matching the incoming speech with the stored templates. The template with the lowest distance measure from the input pattern is the recognized word. The best match, which would be the lowest distance measure, is based upon the dynamic programming. This is called a dynamic time warping word recognizer. Here's a sample of a dynamic time warping, which is the combination of two words, sequence A, sequence B, or two utterances, and they've been dynamically time warped to the center, the section where the vectors are illustrated in the red dots. Okay, I'd like you to go to YouTube. You can click on the link here, skip to the 1 minute 16 second time, and you can observe a student using a DTW voice program to practice learning English. The researchers propose an automatic intonation assessment system. The language student is given a reference utterance. The student listens to it and then repeats it by trying to follow a reference intonation curve that must be imitated. The reference and test utterances are aligned frame by frame using DTW. The resulting reference and test pitch contours are transformed to a semitone scale. Similarity between the reference and test intonation templates is evaluated on a frame-by-frame basis. Instead of computing and comparing the differences between the reference and tests, this paper looks at the correlation between both curves. Syllable stress is assessed by using the information provided by the intonation curve combined with frame energy. Their system is not text-dependent, which means the text transcription of the utterances is not required. Provides an averaged subject-objective score correlation, and the system was tested with the English language, and the researchers are suggesting that it's language independent. The system attempts to decide if two utterances, reference and testing one, from different speakers were produced with the same intonation pattern. This system does not estimate the difference between the reference and the testing, but attempts to compute the correlation between both curves. An algorithm is applied to align both observation sequences. Generally, robustness is a key issue in speech processing, specifically in call applications. Various levels of proficiency and pronunciation of segments may pose problems. Several of the experiments in this paper attempt to assess the robustness of the approach. 4 intonation curves that are typical in the field of linguistics were used to assess: high rise, high fall, low rise, and low fall. Short sentences that did not include uncommon words or complicated structures were used. The 6 sentences or utterances were: what's your name? My name is Peter. It's made of wood. It's terrible. I tried both methods. It was too expensive. Altogether, there were 6 sentences, 4 intonation patterns, equaling 24 types of utterances recorded by 16 speakers, 8 of which were experts and 8 non-experts. 3 different microphones were used for a total of 1,552 utterances. The results strongly suggest that DTW alignment is robust. and the proposed system can accurately discriminate between rising and falling pitch contours. The proposed method requires a reference intonation pattern that the student should try to follow. There's not a clear definition of correct or wrong intonation. Sentences may be pronounced with different intonation patterns according to the context, and in most cases, there should not be only one correct intonation. The problem addressed in this paper is how to teach a student to follow a given intonation pattern as a reference, provided there is not only one correct intonation production. The researchers have created a system to analyze and compare a language learner's ability to copy or mimic expert speaker intonation. How can this research be utilized to assist language learners? Can you suggest other ways intonation can be taught in call? Or do you have any ideas for other applications using dynamic time warping and call?